Okay, so we need to cover one more thing before we actually get into acids and bases, and this is called volumetric analysis. This is a combination of two things which we should be mostly familiar with now. The first is stoichiometry, which you should be good at from first semester, and what we just covered with molarity, so taking moles from molarity and using stoichiometry to solve those problems. So we're going to use it to determine limiting reactants and the amount of products using molarity this time, right? We're going to use stoichiometry to figure out limiting reactant, like what's going to determine how far the reaction can proceed and how much product is formed. We're going to use this with acids and bases coming up. A limiting reactant, this is in a given chemical reaction. The limiting reactant is a reactant which determines the maximum amount of product that can be produced. So for example, let's say you've got a brownie mix requiring 2 eggs, half a cup of oil, and a quarter cup of water. You have 5 brownie mixes, 12 eggs, 4 cups of oil, and 3 cups of water. How many brownie mixes can you make? Which ingredient limits this? Okay, so in an attempt to solve this problem, I'm going to go ahead and just draw everything out here. Right, we had 5 brownie mixes, so those are our large squares. We had 12 eggs, so here's kind of our guide. Each brownie mix requires 2 eggs. Well, that means we're going to use 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we have 2 leftover eggs. Okay, so so far our brownie boxes are limiting how many batches we can make, right? It needs a half a cup of oil. Well, we have a total of 4 cups of oil. Well, 1/2, 1, 1.5, 2, 2.5 means that we've got another 1.5 cups of oil left over. And then it requires a quarter cup of water. So quarter, 1/2, 3/4, 1, 1 1/4. That means we have 1 3/4 cup of water left over. So when we're looking at the ingredients here, the thing that's limiting it is the brownie mix, right? Okay, the actual mix, brownie mix. That's what is we would call this the limiting reactant, which we'll abbreviate just LR here. Okay. Meaning that it's the amount of boxes of brownie mix that we have that's limiting it. It's not the eggs, it's not the oil, it's not the water, it's the mix. Okay, so now that we've kind of seen what a limiting reactant is, let's apply it to a chemical equation. So we've got an equation here, all right, and we've got several questions, okay, sort of in a stoichiometry style. So the first thing to do is balance it. Well, we've gone ahead and done that, just put a 2 there. But we're going to answer these next questions on future slides so we have enough room for it. It says if 10 milliliters of 0.500 molar CuCl2 reacts with 10 milliliters of 0.35 molar Na2S, what's the limiting reactant? So it's either this one or this one since it's a reactant. What's the mass of CuS produced from this reaction? We'll see how to solve that. And then what's the concentration of NaCl when the reaction is complete? So there's several parts to this for us to solve. Okay, so what we need to do here to figure out which one's the limiting reactant is set up basically 2 lines of stoichiometry. One where we're turning CuCl2 into one of the products, and one where we're turning Na2S into the same product, whichever one we pick. We're going to pick CuS because part C is going to ask about the mass of CuS. So we're going to pick that one so we don't have to do extra work for part C. And what we want to do here is set up 2 lines of stoichiometry, right? And with a stoichiometry problem, the first thing you want to do is turn your starting substances into moles and then use a mole ratio and go from there. Now, previously, we did that with grams and molar mass, right, where you take grams divided by molar mass to get into moles. Here we've got molarity and volume. So we're going to set up the first one here. The start of it, we're going to use molarity and volume instead of grams and moles. Well, if we look at our original equation here for molarity, which is moles divided by volume, which is liters. To get that into moles, to rearrange that to moles, moles are going to be equal to molarity times volume. So this is what we're going to start with here, molarity times the volume of the substance. That'll give us the moles of that particular substance, and then we can proceed with the stoichiometry. So for the first one, we'll just label this CuCl2, so we'll make it really clear which one's which. All right. We're going to take the molarity, 0.500 molar, CuCl2, multiply that times a volume. Now the volume has to be in liters, so make sure we're careful here with that. We're then going to multiply times a mole ratio of what we're looking for. We're looking for CuS over what we started with, and that is a 1/1 ratio. Okay, and then we're going to finish that off by multiplying times the molar mass of CuS. And that is, let's see, 95.62. Okay, and then typing that all into a calculator, we have 0.5 times 0.01 times 1 times 95.62. We're going to round this to three significant figures. We have 0.478 grams, okay, of CuS. We're going to do this a second time now, but we're going to use Na2S instead and see how much we make of the same product. We could pick the NaCl, that's fine, but again, it makes more sense because the next question is going to ask about C. So we could, if we did NaCl here, we would do NaCl on the next one as to what we're turning it into, but we're going to pick the same product, we're picking CuS. So this time around, the molarity is 0.350 molar, not a very good 5, there we go. Let's label that. Let's go back, 0.350 molar Na2S, and we have, again, 10 milliliters of it. Make sure it's in liters when we're plugging it in here to make sure we get that into the proper moles. And then our ratio is 1 mole of CuS for every 1 mole of Na2S, and we'll multiply times the molar mass of 95.62 grams of CuS. Okay, and three significant figures again, 0.350 times 0.01 times 95.62, and we're going to get 0.335 grams of CuS. So we have two values here. We have the value from how much CuCl2 can make, and we have the value from how much Na2S can make. And much like the brownie batter example, whichever one makes the least amount, that's the maximum we could possibly make. So really our answer here, okay, what's the limiting reactant is Na2S because it makes the least amount of product. And very conveniently, this is going to be the answer to C here in just a moment. 0.335 grams of CuS is the maximum amount of CuS that we can make. Okay, we don't have enough stuff to make 0.478 grams, right? Going back to that brownie batter example. Okay, we just covered this on the previous slide. It should be 0.335 grams of CuS. Okay, so we're going to go ahead and make sure that's balanced. What is the NaCl concentration when the reaction is complete? Okay, so now we're going to use the information that we know which thing is the limiting reactant. We said the limiting reactant is Na2S. Okay. Remember, this concentration, right, is molarity, which is represented as moles divided by volume. So what that means is I need the moles of NaCl. I also need the volume of NaCl solution, whatever that is. So we got to find a way to figure out both of those. Well, to figure out the moles of NaCl, I'm going to use the information from my limiting reactant. So let's label this here, moles of NaCl. So how do we find the top part, okay, of my equation? Well, we're going to start with the limiting reactant information. Okay, our molarity for the Na2S was 0.350 molar, and our volume was 10 milliliters. Okay, and then we would go straight into the mole ratio. Well, we're turning it into NaCl this time, so it's 2 on the top over 1 mole of Na2S. And I don't need to do anything else because if I stop here, my final unit is moles of NaCl, which is what I want the top of this to be. Okay, so plugging that into a calculator and giving an answer to three significant figures, 0.35 times 0.01 times 2, this is 0.00700 moles of NaCl. Okay, so we have the top part of what I need to calculate. The volume on the bottom, well, that's just the two solutions mixing together, right? You had solution number 1, and then you added to that another solution, right, of the same volume. Well, this was 10.0 milliliters, and this was 10.0 milliliters. So together, that is 20.0 milliliters, or since we have to write things in liters, 0.0200 liters, right? That's what's going to be on the bottom. So calculating the concentration for this, for NaCl. Okay, the top is the moles, 0.00700 moles. The bottom is the volume, 0.0200 liters of the two things added together. Okay, and that's going to give us a concentration of 0.350 molar. Okay, so there's your concentration of NaCl when this whole thing is finished. There won't be a follow-up problem at the end of this. Instead, I just want you to try your homework directly. So go straight to that.